This is number 43 on page 115. This is 20. Okay, my bad. Yeah, 27 is the first one. This is number 27. So we take the original function, and you got to just algebraically expand it, and then rewrite it as 3/8 times x to the negative 3. Then we just apply the power rule. 3/8 times negative 3 is negative 9/8 times x to the negative 3 minus 1, which is negative 4. And then rewrite it, it's negative 9 over 8x to the 4th. So, straightforward problem there. 43 is one that I call a divide and conquer. This is number 43. So this is the original problem. The way to do it is you divide each of the terms on the top by the term on the bottom. So one at a time. I did one like this in example 2. X to the 3rd divided by x squared. That's x. Minus 3x squared over x squared, which is 3. Plus 4 over x squared, which is 4x to the negative 2. Now it's in a form where we can apply the power rule. The derivative of 1x is 1. The derivative of negative 3 is 0. And the derivative of 4x to the negative 2 is negative 8 times x to the negative 3, which is minus 8 over x cubed. And then if you get a common denominator here, you got to multiply the 1 by x cubed over x cubed. Then you can combine the numerators, and it's x cubed minus 8 over x cubed. So that you can look at further. So that's how you handle those. So to the backboard, we've got a few more to go. Bitsy. Thank you. So I'm going to run through these one at a time. Number 55, find the equation of the tangent line for that function at that point. This has been a common question, hasn't it been? Find the equation of the tangent line at a particular point. The only thing that's going to differ here is what the function looks like. So here we go. Oops. This is x to the 3rd. That's the original problem. So that's really hard to figure out how to do it to find the derivative right now, so we're going to rewrite it. This is 2 over x to the, you got to know that this is the same as 3/4. Power and root. Power and root. Then I'm going to rewrite this as 2 times x to the negative 3/4. Now this fits the mold of the power rule. So just apply the power rule. So f prime of x is equal to 2 times negative 3/4 times x to the negative 3/4 minus 1. I always like writing that out just because I make mistakes on that. So that gives you, let's see, 2 times negative 3/4, that's negative 1.5 times x to the, now negative 3/4 minus 1, I like to think of this as minus 4/4. So then I can go negative 3 minus 4, that's negative 7/4. And then rewrite it so it's in a decent form. This is negative 1.5 divided by x to the 7/4. And that's what this is what our derivative is. Okay. So step 1, find the derivative. Step 2, find the slope at that point. So next I'm going to go f prime of 1, because I'm using the x value. We plug a 1 in here, raise it to the 1 to the 7th power, and then the 4th root of 1 is just 1. So this answer is negative 1.5. So the slope at that point is negative 1.5. We already have the point, this is the slope, so we can go straight to the equation. Y minus 2 equals negative 1.5 times x minus 2, and then clean it up from there. What's that?
X minus 1.
Oh, my bad. X minus 1. Thank you. Good? The steps are the same. Find the derivative, find the slope, find the point, write the equation. 63 is a different kind of question. It says find k such that the line is tangent to the graph. So this is the line, y equals 4x minus 9. This is some parabola, but we don't know what this coefficient is. That's what we got to figure out. So if you're really stuck on a problem where you're like, I have no idea what they're really asking, try to draw it out. Okay, so this is how I would handle this. I'd try to draw some graph here. 4x minus 9, that's something that looks like this. Down here, I got a 9, and I got a slope of 4. So this is my line, y equals 4x minus 9. This line is supposed to be tangent to that parabola, a parabola that I would draw here. And so a parabola being drawn on here, I see it's got a positive 1, so that means I know it's going up. And so it would have to go something like this, so that I have some sort of point of tangency. Now I don't know where it is, but I know that this parabola could go shifting anywhere along this line, okay? And this is what we're trying to figure out, where that thing belongs. And we can figure it out using the calculus. So the thing that I want you to see is that the slope of this thing is 4. It's the derivative of this one. Okay? So that means if I find the derivative of this thing, okay, I'll do it right away. F prime of x is equal to 2x minus k. Okay. If I take this derivative and I plug it in for, I set the derivative equal to 4, I'm going to get closer to the answer. So I say 4 is equal to 2x minus k. The derivative has to equal 4. Because the slope at this point, f prime, has to also equal 4. But that's a problem. I got a single variable, I got a single equation, and I got two variables, k and x. So the other piece is the fact that this point, they have to share the same x's and y's. That means when I graph this one and I graph this one, they both have to touch, which means I can set the y coordinates equal to each other. So this is going to mean I've got x squared minus kx equals to 4x minus 9. The y coordinate for the function has to equal the y coordinate for the line right at that point. So wait a second. Somewhere along the line, you guys learned something called systems of two equations, two unknowns. That's exactly what we have here. But you guys learned it like this. 3x minus 4x equals 9. 2x plus 4x equals 7. Solve for x and y. Remember those? Okay, they never look like this, but this is the same thing. I've got a system of two equations. So what we're going to do is, I don't know, I think I'd rather, I don't know what I want to do here. We got to solve for k. So what I'd probably do is solve one of these for x or y and plug it in, or x or k, and then plug it into the other one. Let's solve this one for, since I don't want to, oh, it's kind of ugly. It'd be probably prettier to solve this one for k. K is equal to 2x minus 4. So I'm going to plug a 2x minus 4 in for k and then solve this. So x squared minus 2x minus 4 times x is equal to 4x minus 9. I'm doing a substitution. So what do we get from this? I got x squared minus 2x squared plus 4x equals 4x minus 9. Okay, what does this get us? Throw everything on one side. We got negative x squared, 4x minus 4x, that's going to be 0, plus 9 is equal to 0. So this means x squared is equal to 9, which means x is equal to plus or minus 3. This is one of those cases where you get an answer of two answers because you're solving an equation. We get two possible answers. Well, the original problem was to solve for k. So that means we're going to take the x values, we're going to plug them in, and so k is equal to 2 times 3 minus 4, which is 6 minus 4, which is 2, and k is equal to 2 times negative 3 minus 4, which is negative 6 minus 4, which is negative 10. So this appears that there's two answers for k that give you the places where this line is tangent. So if you were to graph the line f of x equals x squared minus 2x, and f of x equals x squared plus 10x, both of those would be tangent to the line 4x minus 9. And none of the other ones would. Okay? All right. 75 says, show that the graph of this thing does not have any horizontal tangents. Okay, I need an algorithm here. Algorithm is a term that we use in computer science. An algorithm is just a plan. I need a plan. What has to be true if this thing does not have any horizontal tangents? What does that really mean? What does the math, what is going to prove it by using the math? The derivative can't equal 0. Exactly. So what we're going to do is we're going to find the derivative. We're going to set it equal to 0. And we're going to see if there's no numbers that make that true. So the derivative of this is 3 plus the cosine of x. Find the derivative and set it equal to 0. Okay? And then we're going to look for x values that would make the equation true. This would mean that the cosine of x is equal to 3. Negative cosine. Or cosine is equal to negative 3. Right, like that. Okay, think of unit circle. What x values make the cosine give you an answer of negative 3? None. Okay? Nowhere on there. So this is no solution. This is a proof of the fact that x does not, that function, when you draw that thing, it doesn't have any horizontal tangents. It never levels out like this so that it has a horizontal tangent. Never happens. AP style question, AP style question. Just an FYI. Okay? You don't get the basics, you get the in-depth ones on the AP test. Okay, the last one that we're going to do is also an AP style question. And it was number 113. So it said find A and B. Find A and B such that f of x is differentiable everywhere. And it's a piecewise function. F of x is equal to, and it gives you this weird thing, ax to the third for x less than or equal to 2, and x squared plus b for x greater than 2. Okay. Whatever happened to all the numbers? Numbers are gone. Got all these letters. So we got to find the values of A and B. Okay? Stop and think about what this means. So we draw ourselves a picture. Okay? At x equals 2, that's where the magic happens. That's where we have to really be careful. I spy a parabola and a cubic. Okay? So the parabola is x squared plus b. So I don't know. I'll just draw something. X squared plus b. It's going to look something like that. I don't know what. It could be shifted up or down. The other one is ax cubed. Now that's a cubic, and the cubic can be anywhere it wants to be, but what has to happen is, I'll bring it in from this side. What has to happen is these two, if it's differentiable, that means it has to be continuous. So that means we have to fill the hole. But it's worse than that, because not only do we just fill the hole, it has to be a smooth transition, a smooth handoff of the derivative as we go from here over to here. If there's any kind of jerk to it at all, it's a cusp, and it's impossible to find the derivative at that point. So it can't be a sharp turn at all. It has to be this perfectly smooth transition between those two. In other words, the derivative of this one has to equal the derivative of that one at x equals 2. That's the only way we can have a smooth transition. So to handle this, we look at two parts. We look at the continuity part, where do the functions connect, and then the second part is we look at the differentiability. Oh yeah. Believe me. Okay, so here's how you handle each. For continuity, you set the functions equal to each other, and you plug in the magic point, x equals 2. So I've got ax to the third equals x squared plus b, and we plug in the magic point of 2. So it's a times 2 to the third equals 2 squared plus b. Let's clean this up a little bit. This is 8a equals 4 plus b. Okay. That's the continuity half. This allows us to get the right values so that we fill the hole. That's it. The differentiability part is we find the derivative of both, and we plug them in, and we set them equal to each other, and we plug in the magic number. So the derivative of ax to the third is 3a squared, 3ax squared. Okay, that's the derivative of this one. The derivative of this one is 2x. So to fill the hole, we set the functions equal to each other. To find that the slopes are the same, we set the derivatives equal to each other. I can guarantee you that you will see a problem on the multiple choice that looks very similar to this. So this is key. Now, if you plug in the 2 here, you got this, and you got this, and we'll just clean it up. I see 4 times 3, that's 12a equals 4. And now we solve for both a and b. Well, look at this one. We can solve this one easily. This is 4/12, which is 1/3. So we're 1 down with 1 to go. And then we can plug in a equals 1/3 here, which is 8 times 1/3 equals 4 plus b. So this is 8/3 equals 4 plus b. And then we take away 4 from 8/3. 8/3 minus 4 is equal to b. And I'd say 4/3, I'd write that as 12/3. So I got 8 minus 12, which is -4 over 3. These two values are the two values that would go in for a and for b, that this function not only would connect, the hole would be filled, it'd be a smooth transition because the derivatives were equal at x equals 2. Make sense? Okay, that process, that algorithm for finding the solution to a problem like that is something that you're going to want to know. Okay? Okay. All right, well, we only have time for me to go and write down the rule for the quotient rule and maybe take a look at a problem or two. So we're adding to our list of ways we can find the derivative of different types of functions. Isn't that fun? I think so. So yesterday we learned this thing called the product rule. Today we're going to learn this thing called the quotient rule. Okay. So this is one of those rare times where I'm just going to give you the rule. So suppose f of x and g of x are differentiable functions and h of x is equal to f of x divided by g of x. Then h prime of x is equal to. So what is the derivative of a quotient of two functions? I'm not even going to let you guess on this because you'd never guess it. The thing I can tell you for sure, it's not the derivative of the top divided by the derivative of the bottom. Okay, hang on to your seats. Here we go. It's g of x times f prime of x minus f of x times g prime of x, all divided by g of x, the whole thing squared. I know you would have guessed it, but I just thought, let me do it. In other words, if you have a top function and a bottom function, it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. That's all it is. Okay. So let's do a really simple one, and we'll try to prove something that we already know. So let's pretend that f of x, oh, I got to be careful with how I'm saying this just right here. Let's pretend that y is equal to 1 over x. We're going to just see if this works using a really simple case. Okay, so if this is my function, all right, walk me through this. You got to figure out who's g and who's f, and here we go. All right, who's g? X. So this is x times derivative of f, which is the top, so that's 0, minus 1 times 1. Derivative of x is 1. All over x squared. Agree? Okay. So what does this get us? Y prime is equal to 0 minus 1 over x squared. Or in other words, y prime is equal to negative 1 over x squared. Do we have any other way to prove that, to see if it matches? Can we manipulate this and test it? Sure. We know the product or the power rule. This is y equals x to the negative 1. Right? Okay. So I'm going to find the derivative using the old way that we know. Y prime, negative 1 times x to the negative 2. Clean it up. Y prime equals negative 1 over x squared. Same thing. We're good. I do a simple one like this to make sure you see that this actually does work. Okay? And we just verified it with that. Let's do another one. Y is equal to the tangent of x. Find the derivative. Wait a second, we already know that one. Derivative of the tangent of x is secant squared. Now we're going to prove it. Okay? Tangent is sine of x over cosine of x. That's a function divided by a function. Therefore, we can use the quotient rule. Okay? So now this gets a little confusing, so hang with me here. All right. First one. What's the first one? Cosine of x. It's the g of x. So it's the cosine of x multiplied by cosine of x minus sine of x times negative sine of x. Derivative of the cosine is negative sine. all divided by the cosine squared. And you know we write the 2 here, not after the x, because otherwise it looks like we're taking the cosine of x squared. Okay, well, what does this give us? This gives us cosine squared x plus sine squared x over cosine squared x. Ooh, that looks weird. Cosine squared x plus sine squared x. That's 1. That's our identity. Sine squared x plus cosine squared equals 1, which goes back to the unit circle, and really its foundation is the Pythagorean theorem. So this is equal to 1 divided by the cosine squared of x, bless you, which is secant squared. Yesterday was the power rule. What do you do when you're multiplying two functions? How do you find the derivative? Today was quotient rule. What do you do when you're dividing two functions? And how do you get there? Okay? All right. You basically have almost everything you need to do the whole assignments that do Thursday and Friday. All right, see you tomorrow.